Hello. In this video, we will understand the concept of edge computing. What are its nitty-gritties, benefits, key vendors, and a high-level architecture of edge computing. But before we divulge deep into it, it's important to share that the limitations of centralized cloud computing in handling IoT or maybe applications which are delay sensitive. In fact, there are some privacy concerns also because the IoT or the end device or end host data is sent to the cloud. So there are some privacy and the security related issues also which are faced. And in fact, the scale up of the data being generated thanks to the mobile and the IoT devices which have been introduced. So all these are the issues that the traditional way wherein we have the devices which are sending data to the centralized cloud computing in the cloud servers. So there are multitude of limitations which are coming up, and that is where edge computing comes into picture, which handles all those type of challenges which we discussed about, and hence gives us a high performing scalable solution. So let's divulge deep into edge computing. Edge computing. It's about having the servers or the processing devices closer to the source, wherein the edge computing allows processing and the storing of the data closer to the source rather than data traveling to the longer distance of the data centers which are in the cloud. So all the processing of the IoT devices is done locally by the edge computing devices instead of data going to the cloud or the centralized server for the processing. So that is where the latency and other challenges are taken care by the edge computing. Further, edge computing, since here it is the proximity to the end devices, the benefits that edge computing provides is the reduced latency, which is the hallmark of this technology, improved response time, bandwidth saving, and finally, the real-time applications are also benefited substantially because of this technology. Here is the architecture of how edge computing is placed between the cloud and the end devices. So earlier, how the architecture used to be that end devices, IoT devices, they used to send their data directly to the cloud placed setup, the central server which was in the cloud. Each and every device used to do it. But there were challenges like delay, sensitivity, bandwidth usage, scalability was not being considered, and hence the issues. So that is why edge computing, which is much more closer to that of the end devices. Let us say I have maybe data center or local data center or maybe manufacturing location. In there, either DMZ zone is where the edge devices can be placed, or maybe much more closer to devices like, let us say, trucks, cars, which can get the processing done locally by those edge devices. And because all this processing is being done locally and pretty much close to those devices, the latency related issues are also not being faced. That is one. And secondly, since most of the processing is done by the edge computing nodes which are local, the data that is sent to the cloud is quite filtered and very less. Hence, the bandwidth on both sides is also drastically reduced. And hence, those real-time applications are able to perform much better, high performance, and there is much faster response to the requirements. So this is the key benefit and how the architecture of edge computing is like on a very high level. Benefits of edge computing. The hallmark of edge computing is low latency, wherein the processing of data is done locally, which is essentially important for real-time applications and maybe in case of delay sensitive apps, which are, as an example, autonomous vehicles are there, or maybe healthcare monitoring systems are there, which are pretty much benefited because of the low latency type of setup by the edge computing. Next is the reduced bandwidth usage. Since Edge computing performs a substantial amount of processing. Therefore, lesser data is transferred to the cloud. And because of this, bandwidth consumption on the internet is reduced. So let us say the edge devices and the IoT devices are here, everything is processed locally. So only the filtered information goes to the cloud. Hence, bandwidth consumption reduces. Next is the enhanced reliability. Let's say on the cloud, the central server is down, or maybe connectivity to the end device or the computing device, edge computing device is intermittently failure, or maybe it is down also, or maybe the server is down. Since earlier that used to be a big challenge. However, even if the central server is down over the cloud, still the system remains operational because it is getting all the processing information from the edge computing nodes. And that is thanks to the edge computing technology, which makes this possible, and hence the reliability exponentially increases. The last one is the better privacy and security. Since majority of the data stays within or close to the end device and does not have to travel the internet towards the cloud hosted servers, because of this, the risk of exposure of data during transmission it is reduced, and hence better security and reliability, rather security and privacy is achieved. Key vendors in the edge computing world. So the first one is the AWS. AWS IoT Greengrass and AWS Wavelength are the edge services which empower developers to build and manage edge computing applications. Next is the Microsoft Azure Stack Edge, which is more of a hardware as a service by providing compute, storage, and edge intelligence. The third one is the Google Cloud's edge computing, which is focused on AI and machine learning on the edge. In fact, it allows real-time decision making and data processing. The fourth one is the IBM Edge Computing solution that integrates not only the cloud services but other applications also across hybrid cloud environments. And finally, the Intel based solution, which offers hardware and software solutions, including tools designed to support edge workloads. And that takes us to the end of the presentation. Hope you like it. Thank you.